Okay, hi everyone. We're going to continue again working on exponents and rewriting them. Basically, we're going to really look at this with fractions. We talked about dividing before, but I want to make sure we're kind of on the same page here and really just practicing getting used to this language. It seems kind of confusing when we first started, and I had some really good questions from you guys. So we'll continue with this today, okay? Okay, so here's the idea. What if I give you an expression that says h times h to the 0 power times h to the negative 9. So here's some simple strategies for me to rewrite this problem. You could write this as h to the 1 plus 0 minus 9, and that's okay. Why? Because when I'm multiplying powers, right, if I'm multiplying powers, we're really just adding the exponents. And that works. 1 plus 0. Why did I say plus 0? Because there's a 0 there. 1 plus 0 is 1. And minus 9 is h to the negative 8. Okay, because 1 minus 9 is negative 8. We could do this. If we rewrite this as since it's a negative exponent, it goes on the denominator because you're not from around here. So we moved it to the bottom. Okay. Another way we could write this is just moving all the exponents to their positive side. What I mean is, do you see this negative here? You don't belong here. So you're really supposed to go on the denominator. So instead, let's write h times h to the 0 over h to the positive 9. So once I moved it, it becomes positive. Right? Because you're back to where you're supposed to be. So when I moved it, it becomes positive because you're back to where you're supposed to be. You're back to where you're from. Now that you're back to where you're from, let's start looking at this a couple different ways. If we look at a classic way of looking at this, how many h's do we have on top? Well, I have 1 h and 0 h's. So I'm not going to even write that. Times 1. Over 1, 2, 3, 4, 5, 6, 7, 8, 9. And the idea is we don't want to start writing all these h's anymore because it kind of wastes our time. But if you want to, look, only 1 h divides out. And we're still left with a total of h to the 8 left. And that's like a simple way of understanding what's going on with our exponents. If we're dividing, we're subtracting. If it's a negative exponent, you're not from around here, you're on the other side, and then you can end up either multiplying or dividing. Now, let me give you another problem here. What if I gave you guys h to the negative 3, h to the negative 2, and h to the negative 4? Okay, these are a bunch of h's. Now, again, we could combine these like our rule says, and that is 100% great, 100% awesome. And this would be h to the negative 3 times negative 2. No, not, sorry, plus, oh my gosh, plus a negative 2 plus a negative 4. And if you want, you can rewrite the negatives. A negative times a positive right here becomes a negative. Negative times a positive becomes a negative. H to the negative 3 minus 2 minus 4. Well, how many h's do we have? We have negative 5 and negative 4 is negative 9. Okay. But if I want to spin this around, I like, oftentimes in my brain, it's easier for me to make all the exponents positive. So if I write this, hey, you're not from around here, you're not from around here, and you're not from around here, these guys all go on the denominator. 1 over h cubed, h squared, and h to the 4th. I want you guys to notice that all the exponents became positive because I brought them back to where they're from. A negative exponent means you're not from this side of the fraction. You're not from this side of the fraction, so make sure you go back to your side of the fraction. Now we can say, well, aren't there 1, 2, 3, 4, 5, 6, 7, 8, 9? We have total of h to the 9th now. Now, either of these ways are 100% right, and I just want to make sure you guys can get this straight in your brain, how to write these and how to make sure they're on the right side, if they're positive or negative. Now, as we continue this crazy mess, I'm going to go ahead and put some h's on top and bottom. H to the negative 2, h squared over h to the negative 9. So you see a lot of h's kind of everywhere now. Now, the trick, again, I like to do, and this is the way I sort things out in my brain personally, is I will move the negative exponents to the other side of the equal sign. Okay? So if I want to move the negative 2, you don't belong on this side of the fraction. So go ahead and go back to where you're from. Okay? Negative 9, you don't belong on this side of the fraction, so go back to where you're from. And we are, and h squared, this guy here, hey, you stay on top because you were already positive. Now we can combine it. Again, how many h's do we have on top? I see 9 and 2. They're both positive now, so that's going to be 11. And how many do we have on bottom? We have 2. You could also have taken a shortcut to say, hey, don't we have 2 on top and 2 on bottom? And rewriting it as h 11 minus 2 is h to the 9. Or, see, there's so many different ways of looking at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 2. If we get rid of 2, we still have 9 left. And this is like the longest way, but also like visually the easiest way to look at it too. But please take a look. I have 11 on the top and 2 on bottom. And in fractions, we divide some out. And we divided 2 out. So 11 minus 2, another way of writing it, using our power rules. Okay. Another way is to just write everybody on top. H negative 2, h squared. And if I want to write this on top, that's h to the 9. And we can combine it. Negative 2, h to the negative 2, plus 2 plus 9 equals to h to the 9. So there's a lot of different ways of getting to the same answer. We can go through the classical, just write a bunch of h's. We can make everyone positive, or we can move everyone to the top so we're on the same playing field. And all these are perfectly fine representations. If I give you this next problem with h's, h to the negative 1, h to the negative 24, and h to the 20th power, these are some big numbers. So according to our rule, since we're multiplying powers, we could add the exponent h to the negative 1 plus negative 24 plus 20. Rewriting it, h to the negative 1, a positive times a negative becomes a negative. And hopefully you can see negative 1, negative 24 is negative 25, and negative 25 plus 20 is h to the negative 5. Which says, hey, you're actually on the bottom. It's 1 over h to the 5th. Sure, and that's a perfectly fine way. The other method, making everyone positive. Positive exponents. Well, you're on the bottom and you're on the bottom because negative exponent means you're on the other side of the fraction, but you're staying on top. So h20 on top over h times h to 24. Well, we have 20 on top and 25 on the bottom. Whoops. H to 25. And aren't 20 going to divide out with 25? And we're going to be left with how many on the bottom? How many extra? Whoops. We have no more h's on top, and we have 5 on the bottom. Same answer. Okay. So that's what you're going to do on IXL today. A couple of things that mess kids up sometimes is when we have a zero exponent. Let me just review this part. Review a zero exponent. Now, if I have h to the 0 power, as a reminder, that means I have no h's. So this doesn't mean it's 0. By definition, this is going to be equal to 1. Now let's talk about why that's true. If I say h divided by h, you know that's 1, right? H divided by h, like 5 divided by 5, 10 divided by 10. I have 1 out of 1 friend. Okay. Now, if I rewrite this as h times h to the negative 1 power, how do I do that? If I take a value on the bottom and I move it to the top, we give it a negative exponent because you don't belong around here, right? You don't belong here. You're on the wrong side of the street, boy. And then we're going to add the exponents. H to the 1 minus 1. Folks, what's 1 minus 1? Isn't that 0? So h to the 0 is equal to 1 because that's what we initially said this was. So this is the reason why h to the 0, any variable to the 0, is equal to 1. Let's try this with numbers. 5 divided by 5 is equal to 1. We know that. If I want to rewrite it as 5, I want this to go on top, times 5 to the negative 1 power, that's also completely valid. Negative exponents means you're not from around here, so it's on the opposite side of the fraction. We can write it on the wrong side. You just need this little pass, right? The little negative sign is like a pass to the other side. If we want to combine these, 5 to the 1 times 5 to the negative 1, we add our exponents, equals to 5 to the 1 minus 1. Hey, 5 to the 0. What's 5 to the 0? Well, we said 5 to the 0 is the same as 5 over 5, which is 1. And that's the proof of why any variable, any value to the 0 power is equal to 1. Now let's take a look at this slightly more complicated looking one. H times h to the negative 15 over h to the 0 times h to the 5th power. Okay, looking here, does any of these values already not really matter? Okay, which of these can we kind of get rid of already? And hopefully you're saying h to the 0. So what's h to the 0? We said that's just 1. Where can we put this negative 15? Does it belong on top or on bottom? It belongs on the bottom, right? So let's rewrite it as h over h to the 5th, h to the 15. And now let's go ahead and combine our values together. We have h on top. And how many h's do we have on the bottom? 5 on my left, 15 on my right. We actually have a total of 20 h's here. Again, to reiterate, why is it 20? Well, isn't this 1, 2, 3, 4, 5? That's h to the 5th, all being multiplied together. And we're multiplying another 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, if we're multiplying them all together, don't we have a total of 20 h's we're multiplying together? And definitely it's a lot easier than writing out all the h's to remember the fact that powers, exponents, are multiplying quickly. So if I'm multiplying 5 quickly and multiplying them by 15 more, I'm really multiplying 20 of them together. Okay. Now, if I have 20 on the bottom and I have 1 on top, couldn't we say they divide out? And we end up with 19 left. 1 over h to the 19. Now, what if I wanted to do this problem by writing them all on top? H times h to the negative 15, and I'm going to bring up the h to the negative 5. H to negative 5. Remember, it's a negative because when I move it to the other side of the fraction, it changes sign. A positive becomes a negative, or a negative becomes a positive. It's like right now it has a guest pass to come up to the top. You guys ever go backstage? You get like a pass to go backstage. This guy's not backstage. So now we can combine the exponents. H to the 1 minus 15 minus 5. 1 minus 15 is 14. Negative 14. And negative 14 minus 5 is x to the negative 19. Guess what? Where does negative 19 go? Where do the h's really go? On the denominator. So the question here will be express your answer using positive exponents. So whether we're multiplying or dividing, we want to rewrite this so that all our exponents are positive and simplified. That's it. Hopefully by this skill you guys will feel a lot more familiar with moving your negative exponents around. Now, our next task is we are actually going to just multiply out our exponents. We're going to start multiplying out our exponents. So here's my example. It's going to be 5 squared times 5 squared. Okay. So the idea is we're going to set this up, and then at the end you're going to use your calculator. We're going to set this up, and at the end you're going to use your calculator. So first things first, how many 5s do we have? 5 squared times 5 squared. We have a total of 5 to the 4th power. Okay, 5 to the 4th power. Now, what is this number really? This is 5 times 5 times 5 times 5. And since this multiplying 5s isn't that terrible, 5 times 5 is 25. 25 times 5, if you have 5 quarters, how much do you have? You have 125, $1.25. And if you multiply this by 5, you have 625. 5 times 100 is 500. 5 times 25 cents is 125, and that's how I end up with 625. 625. Now I want to quickly go ahead and show you guys how to do this with your, if you guys have an Apple calculator. And there's a lot of stuff on these scientific calculators. So here is how you guys can do it. On the right hand side, let me clear this. So you'll see this XY button. Okay, XY button. This is one of the ways calculators illustrate a exponent. So if you're looking at a simple calculator on your phone or a simple scientific calculator, oftentimes it's written in this XY way. And the way we type this is we type it first X, then Y. And what I mean is, let's go ahead and demonstrate this. If I write 5 to the 4th power, I'm writing 5. Okay, that's my base. Exponent 4 equals, and that gives me 625. So that's what you guys are going to have to practice today while you guys are doing your work using this calculator also. What if it's a simple squared or cube? Oftentimes the calculators will have squared and cubes already here. So oftentimes the calculators will have already squares and cubes already. So let's look at another problem. If I write 3 squared over 7 squared, do we have to move numbers at all? 3 squared and 7 squared? Are they numbers that we need to cancel out? Nope, we don't. So what we can do is, let's go ahead and write 3 squared. 3, and I'm going to hit the square this time because that's faster than hitting the xy squared. And that's going to give me automatically 9. Divided by, what's 7 squared? We had 7 square is 49. Now, are we done or are we not? And the answer is we're done. Why? Because 49 and 7, nothing divides out. And we should have saw that back here because 3 and 9, nothing divides out. Now, some kids, they may get tricked and they'll say, oh, but look, the 9s divide out. No, that's not what division is. Okay, just because you have similar numbers doesn't mean they always divide out. This is really 9 over, isn't 49 really 40 plus 9? And these don't divide out. They're not the same thing. Okay, so we are actually done here. And that's how they want you to answer it in your IXL. Let's look at another problem. So this problem looks like 10 to the negative 1 times 5 to the negative 1. And when I first look at this problem, I'm thinking, oh, hey, look, there's going to be fractions in the problem. And maybe the 5 and the 10 cancel out. But let's rewrite this. Where does the 10 really go and where does the 5 really go? Are they on top or on bottom? If I make this all into positive exponents. If I make them into positive exponents, the 10 is on the bottom and the 5 is also on the bottom. And you can write a 1 if you want, but we only have one of each. And 5 times 10, we don't need a calculator for that, is 1 over 50. And that's it. They want us to rewrite this, evaluate each of these exponents. What if I make this problem a little bit more jumpy? 6 to the negative 3 power over 10. Do we have to move any of these values before we start to evaluate? I would say move that 6, right? 6 doesn't belong here. You actually belong on the bottom. So if I move it, there's no 1 left. I still have to use a 1 if it's on the numerator. 10 times 6 cubed. Now, I'm going to use my calculator here. I highly recommend you always do the most difficult part of a calculator first, if it's multiplication. Because if I write 10 times 6, depending on your type of calculator, it might give you a fudge number. And in this case, it's not. Now, I can write 6 cubed first, and that's going to be 216. And then we're going to multiply that by 10. And that gives us our 2,160. Now, please also realize that, remember, this is on the bottom, so it stays on the bottom. Now, here's our last question. What if I end up with just a bunch of numbers? What if I write 7 squared times 5 squared? Well, on your calculator, since there are no negative exponents here, we're just going to take it as it is. 7 squared is 49 times 5 squared is 25. And then you're going to multiply those two numbers together. 45 times 25. Since the bases are not the same, we treat them separately, right? That's really, sorry, not 45, 49. Oh my gosh. What did I do that for? Oh my goodness. Somebody's probably screaming at me. I don't know why you wrote that. It probably even said 49. 49 times 25. 49 times 25 is 1225. Okay. And that's it.